Hello, my dear students of Benguet State University. Welcome to our online class. I am your teacher, Jan Lasea.
Ladies and gentlemen, a blessed day to everyone. This is my third lecture on our subject, IT 128, Quantitative Methods. Let us continue our learning about understanding word problems. Problem decomposition. Many problems cannot be solved with a single equation. These types of problems need to be decomposed into smaller problems. We solve the smaller problems and then put the pieces together to get the solution to the entire problem. Problem decomposition is similar in computer programming concept called divide and conquer. We divide the problem into smaller problems and solve the smaller problems. Join the solution of the smaller problems into one whole solution and the problem has solved. For example, the problem is find the perfect number. We divide the problem into three smaller problems represented by functions, namely is divisible, is perfect number, and find perfect numbers. When the three algorithms of the three functions are correct, then we join them in order to solve the problem, find perfect number. Consider the problem discussed previously, but with an additional step. Calculate the energy needed to heat water from an initial temperature to a final temperature. The user will provide the amount of water in kilograms and the initial and final temperatures of the water in Celsius. The formula to compute the energy is the amount of water in kilograms times the difference of the final and initial temperatures times 4184. The second sentence, highlighted in bold text, describes actions to be performed by a person before we can do the computation. Thus, this problem has two steps. Step number 1, user input. Step number 2, calculate energy. This kind of multiple step problem is best visualized in a diagram like the one shown above. The figure illustrates the idea of uses. First, the user provides data. Then the calculation uses that data. In this type of diagram, the blocks indicate steps in the solution, and the arrows show the uses of the data. Each of the boxes in this diagram represents a more detailed diagram that describes the actual steps to solve the part of the whole problem. Now consider a more complicated problem. Count how many numbers are greater than the average. When we analyze this problem, we discover the nouns are numbers and average. The verb is count. Thus, this calculation uses two values, numbers and average. This is illustrated in the figure below. We have two nouns, numbers and average, are used by the verb count. However, the average is not a separate, independent value, and it must be calculated. To calculate the average, we need to use numbers. This is shown in this figure. This diagram is important because it visually indicates that what calculations use what values. Second, the order in which the calculations must occur. The first calculation uses average. Consequently, we must calculate average before we perform that step, which is compare and count. The English problem statement may use certain special terms. Terms for computed values. One type of such special terms are nouns that refer to a value and an implied calculation to obtain that value. All of these special nouns are usually followed by the word of, and then the value or values to be in the implied calculation. As seen previously, the word difference is both a noun, which refers to a value, and the result of a calculation. The word inverse is a noun, but also refers to the result of either. For example, taking a fraction and reversing the numerator and denominator. The inverse of 2 all over 5 is 5 all over 2. Dividing 1 by a specified whole number, the inverse of 5 is 1 all over 5. The word sum or total refers to a value which is the addition of potentially many values. These values may be explicitly stated or a range of values may be specified. For example, the sum of all the weights. The word product refers to a value which is the multiplication of several values. These values will usually be explicitly stated. For example, the product of the width and height. The word negative can either be an adjective preceding some value or it can be a noun. For example, the phrase negative total. Negative is adjective. Second example, the negative of the total. This negative is a noun. The word average refers to the sum of many values divided by the count of how many values there are. For example, the average of all the scores. The word number or count often refers to how many items of a certain type there are. For example, the number of values greater than the average. Often, an English statement will not explicitly include a phrase. Instead, it will be implied by the context. Consider this problem. To compute the average of a set of numbers, calculate the sum and divide by how many numbers there are. This problem statement is missing. It missed the phrase of all the numbers immediately after the word sum. The missing phrase is implied by the context of the entire statement. Thus, it is important to look for missing phrases like this one and add them to the problem statement to fully understand the problem. Problem statements often refer to units of measure. Examples, kilograms, days, meters, and so on. To add or subtract two values, they must be measures of the same type of thing. You can add or subtract two distances, but you cannot add a distance and a weight. If two values measure the same type of thing, but are expressed in different units of measure, you must first convert them to the same unit of measure in order to add or subtract them. For example, if you need to add 5 inches and 2 meters, you must either convert the inches to meters or the meters to inches. Units of measure often have the word per. For example, kilometers per hour, miles per gallon, etc. Whenever you see the word per, this is a description of a ratio or rate. The first step to solving this type of problem is to rewrite its ratio as a fraction. For example, 5 miles per hour is 5 miles all over hour. Problems that refer to ratios will often require multiplication. When you multiply units of measure, a unit in a numerator will cancel out the same unit in a denominator. So for this example problem, at 5 miles per hour, how far will you go in 10 hours? We use this formula, 5 miles all over hour, multiplied by 10 hours. The hours cancel each other. Therefore, we are left with 5 miles multiplied by 10, and the product answer will be 50 miles. Sometimes this type of problem also requires converting units of measure. Suppose you have this problem. At 5 miles per hour, how far will you go in 30 minutes? We use this formula, 5 miles all over hour multiplied by 30 minutes. We use this for hours and minutes are not the same and do not cancel. So we must include a conversion ratio. To convert 30 minutes into an hour, we multiply it with this conversion ratio, 1 hour all over 60 minutes. Now the hours will cancel and the minutes will cancel. Thus the result is 2.5 miles. Thus, to solve this type of problem, you need to construct a formula that will result in all of the units being cancelled except the one for the desired answer. Have the remaining uncancelled desired unit in the numerator. To construct a formula, you can invert units of measure as necessary. So for this problem, at 5 miles per hour, how long will it take to go 10 miles? Our answer should be a measure of time in hours. So we invert our miles per hour ratio to get this formula. Hour all over 5 miles multiplied by 10 miles. In this formula, the miles cancel out and we have hour all over 5 multiplied by 10. Thus, it yields 2 hours. By inverting the ratio or fraction, the miles cancel out and thus leaves behind the hour unit. In Algebra 1, we learned ratio and proportion, and it does the same thing. It will calculate the answer 2 hours. Inverting the fraction or ratio is a shortcut. Let us learn understanding word problems by examples. For each of the problems below, identify the nouns and verbs and then create a diagram showing the calculations from a formulated formula. Solve the problems using algebra and trigonometry and show your solutions. Problem number 1. John is 2 inches shorter than Juan. Juan is 62 inches tall. How tall is John? Our solution, we will implement algebraic expression into algebraic equation. Let the variable x be the height of John. According to the problem statement, John is 2 inches shorter than Juan. The height of Kwan is 62 inches tall. Therefore, the algebraic expression x is equal to 62 minus 2 will be our formulated formula according to the problem statement written as a algebraic expression. The nouns that we can identify from the problem statements are the following: 62, 2, and height. The verbs are, the verb is subtract. The highlighted green algebraic expression is our computational model or mathematical model that we will draw a diagram from that formula or algebraic expression. Therefore, the diagram consists of nouns such as 62 and 2 are used by the operation subtract. The operation subtract produces the height. And then this diagram was derived from this algebraic expression x is equal to 62 minus 2. The solution or answer to the problem 62 minus 2, the answer is 60 inches. So therefore, how tall is John? He is 60 inches tall. Problem number 2. A number plus 3 is 12. Find the number. We solve this problem using algebra. Let the variable x be the number. From the problem statement, a number plus 3 is 12. Therefore, we can write that into an algebraic expression. X plus 3 is equal to 12. This x plus 3 is equal to 12 will be our computational model that it will now be converted or transformed into a diagram as we can see here. The nouns that we can identify from the statement of the problem are x, 3, and 12. The verb is add. The diagram shows that the nouns x and 3 are used by the add operation. The add operation produces the number 12. To find the number, we simply apply algebra transposition technique. So this positive 3 will be transposed to the right side and it will become negative 3. So x is equal to 12 minus 3 and the value of x is 9. So the number that we are trying to find is the value 9. Problem number 3. Find 3 consecutive odd integers so that 4 times the first integer equals the sum of the other 2. To solve this problem, we will apply algebraic expression. We are looking to find the 3 consecutive odd integers. So let the variable x be the first odd integer number. To determine the second odd integer number, we add it by 2. Thus, x plus 2 will be the second odd integer number. To determine the third odd integer number, we add with 4. Thus, x plus 4 is equal to the third odd integer number. According to the problem statement, 4 times the first integer equals the sum of the other 2. So 4x is equal to the sum of the other 2. The other 2 referring to are x plus 2 and x plus 4. Thus we have quantity x plus 2 to be added to quantity x plus 4. We simplify this expression so that we can make it less terms. So the simplified result is equivalent to 4x is equal to 2x plus 6. So that when we draw the diagram, the components or entities of the diagram will be less also to draw. Thus, our computational model will be 4x is equal to 2x plus 6. The nouns that we can identify from the statement of the problem are 4x, add integer, 6, and 2. The verbs are multiply and add. Our diagram will look like this. The nouns 4 and x are used by the multiply operation and it will produce add integer. Onto the right side, we translate this 2x plus 6. That's why the arrows direction are from right to the left. So the first math operation will be multiply. The nouns 2 and x are used by the multiply operation and it will produce the product. The product and the value 6 will be added together to produce now the add integer that we are looking for. So that is the diagram based on this simplified algebraic expression 4x is equal to 2x plus 6. The three consecutive odd integers are 3, 5, 7. Let us relearn right triangle trigonometry. This triangle is a right triangle because it has a right angle opposite from the hypotenuse. The angle A is on the opposite of this right triangle. The side A is called the opposite side. The side B is called the adjacent side. Whereas the longest side, name C, is called the hypotenuse. The sine of the angle A is equal to the opposite side divided by hypotenuse. The cosine of the angle A is equal to the adjacent side divided by the hypotenuse. The tangent of the angle A is equivalent to the the opposite side all over the adjacent side. If we inverse the sine of the angle A all over C, it will now become the cosecant of the angle A. The reciprocal of the ratio A all over C, which is C all over A, is the cosecant of the angle A. The reciprocal of the ratio B all over C of the cosine becomes the secant of that angle A. The reciprocal or inverse of the A all over B becomes the cotangent of the angle A. We learned in trigonometry the SOHCAHTOA method of memorizing the trigonometric function. The S stands for the sine, the O opposite, and H is the hypotenuse. Therefore, sine is equal to opposite all over hypotenuse. The cosine is equivalent to the adjacent all over hypotenuse. And then the tangent is equivalent to the opposite all over adjacent. Even though the cosecant, secant, and cotangent are not written out in this SOHCAHTOA, but we can determine them by simply inversing or getting the reciprocal of the ratio. If an observer looks up at an object, an airplane, the sun, or a cloud perhaps, the angle that the observer's line of sight makes with the horizontal is called the angle of elevation. If the observer looks down to see the object, the angle made with the horizontal is called the angle of depression. Here is your assignment. For each of the problems below, identify the nouns and verbs and then create a diagram showing the calculations from a formulated formula. Solve the problems using algebra and trigonometry and show your solutions. Problem number 1. From a location 23 meters from the base of a flagpole, the angle of elevation to the top of the flagpole is 37.5 degrees. How tall is the flagpole? Problem number 2. A person on the edge of a cliff looks down at a boat on a lake. The angle of depression of the person's line of sight is 10 degrees, and the line of sight distance from the person to the boat is 555 feet. How high is the cliff? Problem number 3. The sum of twice a number and 8 is equal to the difference between 4 times the number and 18. Find the number. Lastly, problem number 4. Find 3 consecutive integers such that the sum of the first and third increased by 3 is 50 more than the second. I posted your third assignment in our Google Classroom. Please answer and accomplish it.
That ends our topic for today. I hope you have learned in my class. Thank you for watching. Carry on until tomorrow. God bless us.